Texan Global School. Equality and equations. In this class, we will analyze the properties of equality and the processes to solve equations. An equality is defined as an equivalence relation between two expressions. This is, A equals B, if and only if A and B are two symbols that represent the same. The properties of the equalities are reflexive property, which indicates that every expression is equal to itself. The symmetric property indicates that, if one expression is equal to another, then the second expression will also be equal to the first. The transitive property indicates that, if a first expression is equal to a second, and that second expression is equal to a third expression, then the first expression will be equal to the third. The additive property, in essence, indicates that we can add any value, as long as it is performed exactly the same on both sides of the equality. From this property, it follows that we can add any additive inverse, or we can subtract by any value, as long as it is performed on both members of the equality. Finally, the multiplicative property indicates that we can multiply by any value, as long as it is performed exactly the same on both sides of the equality. From this property, it follows that we can multiply by any multiplicative inverse, or that we can divide by any value, as long as it is performed on both members of equality. From this concept of equality, follows the concept of equation. An equation is defined as an equality that is satisfied for some values of the variable. We can have first-degree or linear equations, which the equality is satisfied by a single value of the variable. For example, 2x minus 2 equals 0. The equality is satisfied if x is equal to 1. In the case of a quadratic equation or second-degree equation, the equality can be satisfied by two values of the variable. For example, x squared minus 4 equals 0. Equality is satisfied if x is equal to 2 and negative 2. For a cubic equation or third-degree equation, the equality can be satisfied by three values of the variable, and so on. For example, x cubed plus 2x squared minus x minus 2 equals 0. The equality is satisfied if x is equal to 1, negative 1, and negative 2. In this class, we will analyze processes to solve linear equations using the properties of equality. Let's look at an example. We will solve the indicated equation. We will use the properties of equality for its solution. Before starting to solve, it is important to analyze the equation and design a solution strategy. We will send the linear terms to the left member and the independent terms to the right. So, we use the additive property, adding 3 in both members. This step cancels the negative 3 on the left side. Now, we will move all the linear terms to the left member. We apply the additive property again by adding negative x to cancel it from the right side. We add like terms and obtain a unique solution of x equals 4. We will verify the result by substituting it in the original equation. The members are performed independently to verify if the equality is satisfied. By substituting from the left side, we get 2 times 4 minus 3, which results in 5. By substituting from the right side, we get 4 plus 1, which results in 5. Since we got the same value on both sides, it means that the result of the equation is correct, since the equality is satisfied for this single value of the variable x. In this next example, we will solve the equation for x minus 8 equals 0. Likewise, we will eliminate the independent term from the left side by applying the additive property. We add 8 in both members of the equality to cancel the negative 8 on the left side. Now, to eliminate the numerical coefficient of 4x, we will multiply by its multiplicative inverse, 1 over 4. Or what is the same, we divide both members by 4. We perform the multiplication between fractions. By definition, 4x is divided by 1. So, we multiply numerator with numerator and denominator with denominator, as we saw in previous classes. We simplify the left member by canceling 4 over 4. And we simplify 8 over 4. We obtain that x equals 2. We will verify the result by substituting it in the original equation. The members are performed independently to verify if equality is satisfied. When substituting from the left side, we obtain 4 times 2 minus 8. And from the right side, we leave 0 indicated. By simplifying the left side, we also obtain 0, thus verifying that the result of x equal to 2 is correct. For this example, a solution strategy is to eliminate all denominators by multiplying both members by the least common multiple. The least common multiple of all denominators is 6. So, using the multiplicative property, we multiply both members by 6. Now we perform the operation by using the distributive law of multiplication. We can see that when simplifying, all the denominators are eliminated, thus facilitating the equation. We apply the distributive property again on the left side, and we simplify like terms on the left side. Now we will send all the linear terms on the left side. We apply the additive property. We add 4x to cancel it from the right member. We simplify like terms, obtaining 7x equal to -12. We then apply the multiplicative property to eliminate the denominator. We multiply by 1/7 on both sides of the equation. We simplify 7 by 7, thus obtaining x equal to -12/7. We verify by substituting the result of -12/7 in the original equation. By performing the fractions, each side independently, we can see that the equality is satisfied, indicating that the result is correct. It is important to note that there are many ways to solve equations. Another option is to solve the algebraic fractions directly and simplify. We propose it as an additional exercise. In this last example, we will solve the equation with decimals. First, we change the decimals to fractions. Remember that 0.08 becomes 8/100. 0.03 becomes 3/100. And finally, 2.4 becomes 24/10. To make the equation easier, we eliminate all the denominators. Applying then the multiplicative law, we multiply by the least common multiple of all the denominators, which is 100. Now we apply the distributive law on the left side. We perform the product of the integer by the fraction on the right side. And we simplify fractions. As we can see, we eliminate all the denominators. Once again, we use the distributive law to perform the left side's product and simplify like terms. We then eliminate the independent term 160 from the left side of the equation. Applying the additive property of equalities, subtracting -160 on both sides, we obtain 5x equal to 80. Finally, we apply the multiplicative property. We multiply by 1/5, thus obtaining x equal to 16. We verify the equation by substituting x equal to 16 in the original equation. As we can see, by performing the process independently, we can see that the equality is satisfied, indicating that the result is correct. Texan Global School. Global online learning. Knowledge for the world. www.texanglobalschool.com